So on page 53, we've got naming ionic compounds. The objective for that is going to be 1.13b. 1.13b. Which is going to be name or write formulas for ionic compounds. Name or write formulas for ionic compounds. Given the other. So we've got single oxidation state or single charge ions that we'll have to be able to name, multi-oxidation state or multi-charge ions that we'll need to name, and polyatomic ions that we'll need to be able to name. So that's what we'll break down today, and then do some processing with that here in a little bit. So first thing we're going to talk through is those single charge ions. Single charge ions. So you've got single charge ions. If I say single, how many is that talking about? One. So a single charge ion is something that only makes how many charges? One. So only one charge. Only one possible charge. Okay, only one possible charge. So go ahead and find Mg. Find Mg on your periodic table.
So we're on page what?
53. So Mg has 2 valence electrons. That means it's going to make a charge of what? Christiana? Exactly. Do you know positive or negative? It is a positive, so it'll make a +2 charge, and it is only going to ever make a +2 charge. Magnesium will only ever make a +2 charge whenever it reacts. That's why it's a single charge ion. Okay? Will it ever make a +3 charge? No. Nope. +1 charge? -1 charge? Definitely not. It doesn't want to gain an electron. So anytime you have Mg, if it's in a compound, you know it's got a +2 charge. As a result, when you name it, you don't have to do anything special with its name. Okay? So it'll be magnesium ion. So you just name the element and then ion. Okay? If we're looking at something like Li, what charge is Li going to make? Peyton, what charge will Li make?
One.
What kind of a 1?
Positive.
Exactly, +1. Any ambiguity in that? Is it going to be anything other than a +1 ever? What do you guys think? Oh, sorry. Is Li ever going to make something other than a +1 charge? No, single charge ion. So then lithium ion will be the name. So the only thing that's odd or different about single charge ions is if we have a negatively charged ion. So let's look at nitrogen. Okay, nitrogen. What charge is nitrogen going to make? It's going to be a negative. -3. So -3 charge. Is it going to make anything other than a -3? Nope. So -3 every time, which makes it a single charge ion. Whenever you see one of those nonmetals, though, those nonmetals, to show that they are the most electronegative in a bond, you change the ending to "ide." Okay, so it's only going to be with nonmetals, and it's only going to be the most electronegative of the two. So right here, you take the first syllable of nitrogen, so nitr, and then in it, instead, you're going to change the ending to "ide." So nitride ion will be what that's called. Right. If it's a negative, it changes. Yep. Lily. So just right now, I'm writing ions to specify that they're ions and not in a bond. But starting tomorrow, you guys are going to have them always in a bond with something, so you won't have to write ion from then on. Okay? All right, so go ahead and fill in whatever information I leave off. Give me Ca and S. So give me what the ion is going to be, what the charge will be, and then what the name of that will be. Awesome. Charge is +2, and then the name on that is going to be what then? Aiden? Exactly, the calcium ion. Then sulfur is going to be what charge? Lily? Exactly, a -2 charge. And then the name on that is going to be what, Carlos? Exactly. Sulfide ion. Okay. Questions on how we're naming those single charge ions? Okay. If we've got a single charge ion, that second one we talked about on objective was we need to be able to name multi-charge ion or multi-oxidation state ion. So multi-charge ion is how I refer to it. Okay. Before I move on to multi-charge ion, I want to tell you guys which ones are generally the single charge ions. Okay. You guys probably have already kind of made a picture in your brain about where those are on the periodic table, though. But they are typically groups 1 through 2 and 13 to technically 17, because does group 18 make ions? No. Nope. So technically 1, 2, 13 through 17 are going to be the single charge. Now, there are some exceptions to that, but very few, and we don't see those a whole lot. Okay? Then multi-charge. If single charge ions had only one possible charge, then what are you thinking multi-charge ions mean? Multiple charges. Exactly. If we've got multiple possible charges, so 2 or more possible charges. So these are ones that they can't necessarily make up their mind on what charge they want to be. So sometimes they're one way and sometimes they're another, right? If I were to kind of make an analogy here, the single charge ions, those are your friends that you like. They are them no matter who they're around, right? They're always the same person. You can rely on them. You know who they are, and they're going to be consistent no matter what, right? Those are your single charge ions. Multi-charge ions, those are, if you know your friends who, like, sometimes they act one way around one group of people, and then whenever they're around another group of people, they act a different way. You guys know what I'm talking about? So those are your multi-charge ions. Those are your multi-charge ions where it depends on who they're with that tells you what charge they're going to have. Okay? So, for example, iron, Fe, pretty commonly can be a +2 charge, and it can also pretty commonly be a +3 charge. Okay? So it can be a +2 and it can be a +3 depending on the circumstances. Okay? There are other options, but those are some of the most common. Now, if I told you the name of the iron was iron ion, would you be able to tell which of those two I'm talking about? So I'm going to have to give a little bit more information whenever I come up with my name. Okay? The way you do that is you use a Roman numeral. Okay? So we look at what charge the ion is, and that tells us what Roman numeral I'm going to put after the name of the metal. So this is going to be iron Roman numeral 2, ion. And you read that iron 2 ion. So you guys can probably figure out from there what that Fe +3 is going to be, right? What's the name on Fe3 going to be? Iron Roman numeral 3, iron 3. Ion. If I was looking at like nickel, Ni, nickel pretty commonly is either a +2 or a +4. Again, just like iron, it can be other things, but those are two pretty common ones. Ni +2 is going to be what name? Dominic? Exactly. Okay. And then nickel 4, what's the name for nickel 4 going to be? Holly? IV is the Roman numeral for 4. Cool. So that's what you do here. So for these multi-charge ions, you've got first name the metal. Okay. And then second, show charge with Roman numeral. I'm going to shrink this down a little bit. Give me a little more space. So, have you guys dealt with Roman numerals some before? A little bit. So I'm going to do a quick recap so that you guys have a reference for what those Roman numerals are. So Roman numeral 1 is going to be I. Roman numeral 2 is II. 3 is III. We're going to skip over 4 for a second and go to 5. Roman numeral 5 is going to be what? V. Exactly. The way I remember the ones that are around V and around 10 is I'm referencing in comparison to 5. Okay? So how many away from 5 is 4? It's -1, so it's going to have I in front of the V to say the number right before 5. Okay? That means 6. Where is 6 in relation to 5? Right after it, so VI to say the number right after right after 5. So 7 is VII to say 2 after 5. 8 VIII. And then 9 we're going to skip. 10. Do you guys know Roman numeral for 10?
X.
It is X. And then so 9 is going to be IX, the number right before X. Okay? Now, just a heads up, we typically use 1 through 4 pretty regularly in multi-charge ions, occasionally use 5, and then I've never seen anything above 7, all right? Just kind of for some context, but that's them in case you ever needed them, okay? Questions there? Okay, I'm going to go ahead and clear it and give you guys a couple of examples. Okay. All right. We've got so first I want you to do CR with a +2 charge. What's the name for that going to be? I also want you to do what it would be if you had copper +4 and titanium 1. Chromium.
2.
Yes. Chromium 2 ion. Then Cu +4 is going to be what, Brianna?
Copper. The
IV ion. And again, when you're explaining it to me, by all means tell me IV. The way you read that is copper 4 ion. Okay? Then titanium 1 is going to be what ion, Emma? What's the titanium 1 ion? Ti +1, exactly. And then copper 5 ion is going to be what, Peyton? The last one. Copper 5. Awesome. Cu with a +5 charge. Cool. Questions about any of those? So the last one is polyatomic ions. Polyatomic ions. So what you need to be able to do with polyatomics is recognize the formula or name of common, bless you, polyatomic ions. So if I'm using the word recognize, okay, what does the word recognize mean? Say again? Right, to realize, to see and acknowledge that it's there. Okay? So, if I say recognize, then do you need to memorize them? You do not. No. You do not actually have to memorize these. You guys need to be able to recognize, like, oh, okay, there is a polyatomic ion. You don't need to know what the polyatomic ion is. Just recognize, like, hey, there is one. And then what you'll do is find polyatomic ions on a chart. So the few things that are going to help you identify and recognize the polyatomic ions. First, what does the prefix poly mean? So whenever you see polyatomic, you should recognize, okay, there's quite a few atoms in that ion, okay? So if I'm looking at a compound, I'm going to give you something like an example of this would be like Na is a +1 charge bonded with SO4 with a -2 charge, okay? This right here is a polyatomic ion because it's got S and 4 O's. So that's a polyatomic ion. You'd need to be able to recognize that SO4 as a polyatomic ion, okay? When you look it up on the chart, that is sulfate, okay? Sulfate is this polyatomic ion, sulfate. So how you would see that on a worksheet is Na2SO4, and you need to be able to recognize, okay, right there, that's a polyatomic ion because Na is going to be a single charge ion. Okay. In contrast, you also would be able to see like magnesium phosphate. Okay. Magnesium phosphate. Magnesium, is that a polyatomic ion? Or is that one of the single charge ions we talked about first? It's one of the single charge, so it's definitely not that one. But right here, I look at phosphate. The ending for those nonmetals that were single charge, what did the ending change to? This one is 8. The single charge one ended in "-ide", so that's how you can tell the difference. Again, that's how you can recognize polyatomics. Is this one ended in 8, so I know I need to go look on my chart. Okay? Questions on that? Okay.